You are live. It is live now. Can everybody hear me now? Can somebody respond in the chat, please? It says no live. Somebody says no live or no sound.
It wasn't for a while. It wasn't, but now it should be once you
So, okay. Steve Brock. Can anybody hear me yet? Oh, you can hear me. Got it. Perfect. Perfect. All right. Hello, guys. I hope all is well. Looks like we have a lot of people at home checking into the Access Control 101 webinar. If you guys are wanting to receive CEU credits for this event, you'd have to email travis.howell@hlflake.com. I'll repeat it again as we go into the lesson. Is it all clear for you guys? Audio sounds clear? Barbara, enlarge how? What is not? What issue are you having? All right, yes, good, perfect. Okay, well, I'm going to go ahead and get started. If there's any questions, you guys can leave questions here. And also, since we have so many people in the room, answering all of the questions may be a little difficult. So you can email me at brenton.webb@hlflake.com, and I'll send it in the chat right now. And you can email me any questions that I may not be able to get to today. And I'm going to go ahead and get started right now. So, Access Control 101. And I'll just start with me. About myself, my name is Brenton Webb. I was doing integration for about 13 years, which just means I was doing access control and video for large customers like Shell and Chevron. Those were the environments that I worked in, a lot of hospitals. I'm originally from New Orleans. I have an associate's degree in computer and electronic repair, but my original choice I started was body and fender. But needless to say, I didn't choose the automotive route. I stayed with the electronics. We moved to Houston here in 2005 due to Hurricane Katrina. And in 2006, I started doing integration for a small company called Access Security Concepts. I moved around a few times. I went from Stanley. I did subcontractor work. I worked for Convergent, Intech. And I know it shows that I've been at HL Flake for 6 months, but now I've been here for today. Makes 1 year exactly, 365 days today. HL Flake has been expanding their offering in access control market, and that's why they brought me in to help you guys with access control. So questions, quoting, just helping you guys get started and understand and getting you the right product for the situation that you'll get into when installing access control. And Travis just posted a note again to email him if you want your credits for CEU. Any CEU credits, email travis.howell@hlflake.com. Appreciate it, Jeff. And Mike, yes, 365 days. So here's our all of HL Flake's brand. So we have HL Flake, we have McDonald's Dash. We've merged with International Key Supply and H.E. Mitchell. And we also have our Jacksonville location. So we're shipping out of all locations now. And free ground freight with any order of $100 and over. If you need anything, you can get orders from all of these branches. So what is electronic access control? You may hear it referred to as EAC. For electronic access control, it may just be access control. But access control, a system that determines who is allowed to enter or exit a facility, where they are allowed to exit or enter, and when they can allow, when they are allowed to enter or exit. The access control controls all of those options. So EAC uses computers to solve limitations of mechanical locks and keys. So maybe a full computer, a desktop, laptop, or maybe just a standalone unit, which has computer components in it, which allows you to use access control. Access control system, it grants access based on the credentials presented. So a credential could be a card, can be a key fob, can be a fingerprint, a face, finger vein. There's going to be some more to probably come out with the current situation we have going now. We may end up with a few more biometric ways of entering a space. So when access is granted in the access control system, the door is unlocked for a predetermined time, and that transaction is recorded. When it is denied, when you get access denied, so if you have a card and it is not programmed into a system and it does not allow you into a system, that is going to be called access denied. The door will remain locked, and that attempted access will be recorded as well. In the access control system, it can monitor the status of a door, but you must use a door contact in order to do that. An alarm of a door forced open or held open can be set to trigger in the software as well, just depending on how long you have your, say, hold open set for. Later on, maybe in a couple weeks, we'll do some more videos. I'll go over softwares. I'll probably I'll get you guys to send out some questions. Let me know if there's some softwares that you guys might want to see, or some devices you might want to see tested online. We'll go over that. Yes, I can get that email. Presentation can be emailed. You just let me know if you need it after the show. To Jeff Moss. But what I was talking about, the door contact. Door contacts are really important in access control, but I noticed a lot of people are not using them. They're really cost effective. They're not expensive. So I would recommend, if using a full network system, using door contacts, but we'll go over that a little later as well. And if there's any questions, you can send that over to me. So when a credential is presented to a reader, the reader sends the credentials information, usually a number, to a control panel. The control panel compares the credentials number to the access control list, and it's going to grant or deny the access. And it sends a transaction log to a database. So in a network system, you'll start to hear database that term, you need to get familiar with it. Just get used to it. The database is where all the information is stored. So all of the card holders um, would be the database. And when you install a fresh access control system from scratch, you build the database. Just keep that in mind. Database is going to be something that you, if you're going to do networked access control, something to just remember. You're going to hear it quite often. So when access is denied based on the list, the door remains locked. And if a match between the credential and access control list, the control panel operates a relay that in turn unlocks the door. So in the software compare a credential to a list. If you are in that list, it'll grant access. And then in turn, it'll trigger a relay. And a relay would allow you to unlock a door. If you're going to get involved in access control as well, relays, we should become familiar with relay and relay technology. Maybe later, I think next week or in another 2 weeks, I'll go over using multimeter and go over testing relays, show you how it works, and we'll do it live. We'll have a webinar on that one as well. So the control panel ignores a door open signal to prevent an alarm. Often the reader provides feedback such as a flashing LED for access or denied and a flashing LED for access granted. So when you have a network system, you can wire your readers in and use the LED. And the LED feature would allow you to have a visual indicator on when you get access granted or access denied. The LED on the reader would trigger no matter if you terminate that LED cable. It's going to trigger regardless once you put a card to it. But if you wire the LED to the control panel, when access is granted, it'll generally throw a green LED and you'll be able to see it on the reader when access is granted. I am a big believer in using LED. I will not wire anything up without it if possible. It's a visual indicator that would allow you to tell when your reader is actually functioning correctly. It just helps in the long run having that LED. Just keep that in mind. We'll go on to the next slide. So our types of systems, you'll have wired access control and wireless access control. So a wired access control system is going to require you to run wires from a controller to each door that you like to have controlled by a card reader. So in a wired situation, sometimes you may have a card reader that's 50 feet, so you're going to run 50 foot of wire. Sometimes that reader may be 200, 300 feet. You'll have to run it 300 feet to get it from door to controller. Wireless access control generally uses wireless locks, and they can communicate via Bluetooth, Wi-Fi, hardwire, and our gateways. There may be a few terms that I don't have listed, but the locks have to communicate somehow. There's a lot of technology out here that locks can communicate on, but generally what we have, it'll be Bluetooth, Wi-Fi, hardwire, or gateways. So take a special note to there are wireless locks that will work with wired access control systems, and the opposite. There are hardwired locks scenarios for wireless systems. So for majority of the companies, so like Engage, Allegiant Engage, Alarm Lock, if you were using an Alarm Lock wireless reader and using the network's setup, and you have a scenario where a wireless application wouldn't fit, you can get an Alarm Lock hardwired device. Same with Engage. If you were using their wireless platform and you needed to go wired, you can, and vice versa. You can do both and use wireless or use hardwired for this Alarm Lock and the Engage technology. So now we're on to our types of access control system. So I came up with a few types of access control. So our first one, which most of you are probably already aware of, standalone access control, which all programming is done at the keypad. We have server-based access control systems, embedded web server, which I call web-based, but we named it embedded web server because every manufacturer will have it named something else. We have the cloud-based solution, and we have an app-based solution, and that is our 5 types of access control systems that you can pick up from us. If there's one that's not on the list, somebody let me know, but this is all that I've seen in my 15-year career of types of systems. I'll cover each one and how each one functions, and I'll have a demo as well. So for standalone, below is just a few options that we have in standalone. HL Flake carries all of those that you see at the bottom. You can pick up through us. But standalone system is the most cost-effective type of EAC system. Comes in proximity, keypad, biometric, and our facial recognition readers. And it is by far the easiest to program. All programming and wiring is done on the device. Standalone, it has everything you need to function on board the device, which makes it really easy to set up and install and program and get the job done fairly quickly. So all of your outputs, inputs, and the database is all stored locally on each one of these devices. We have any questions so far? No, no questions. Okay, I'll go on to the next, server-based systems. This is just an example of standalone and how you would communicate to a standalone device if you had a computer involved. So the only one of these that would use a computer would be the TF1700. That would be the only one of these devices that would use a computer when programming. 2323. Here's our Seiko Alarm SK2323 standalone reader. And here is a Prox standalone card reader, which I like that one quite a bit. So next in line is server base. Here's a few options that we have that we carry. We have a CANSEC, ZK Teco. This is Alarm Lock's hardwired controller that works with the network system. This is a Dormcabo's Keyscan Luna. Here's a Carry controller and Roslayer. So in a server-based system, this system requires a PC. It can be a desktop, it can be a laptop, but you need a computer, and it's called a server. So where everything will be stored. And a controller and connection to the internet for communication to the controller. So when working on a server-based system, you typically would mount the controller in a secure space like an IT closet, just somewhere where can't easily be accessed. And in order for you to program it from your desk, you'll need to have it plugged into the network. Software must be installed in a server-based scenario. You have to install it on that machine that the database will be stored on. So it'll have to be installed on the server. If another PC will connect to the controller as well, that'll call it a client PC, and the software will have to be installed on it as well, on your client PC. All of the programming in server-based scenario, database changes, IP addresses, the door contacts, request to exit, your locks, credentials, etc., will have to be done on the PC and then saved to the controller. So when you're starting with these network-based systems, you can you have to program the whole system from scratch, which each manufacturer has a different type of software. And like I said, we'll eventually go over some softwares here in the next upcoming days or weeks to cover some more. All of the transactions are stored on your controller. So when you use your badge, everything will be stored here on controller. And if a connection is lost between the controller and the server, the system will still function, but updates to the controller can't be made until communication is established. So for example, any one of these network controllers that you see here on this page, if I were plugged into them and then the cable gets disconnected, the network cable, you will no longer be able to access it and make changes in that controller, but the controller will still function as normal. It'll still allow access, grant access, deny access to those who are already in the system, but you won't be able to add any new time zones or card holders or anything like that until you reestablish communication via network. And we're going to go on to the next slide. And I see this comment about the alarm lock seminars. Yep. Alarm lock, Mr. Andy Phelps, he does a great job in his presentations, and he has quite a few videos on the network's alarm lock setup. So it looks like I'm missing a picture, but it'll work. This picture, I had a picture here on the database stored for this ZK Techo C3100 panel, but this is just an arrows, just showing how communication works. Above where C3 panel should be there, but I'm not sure what happened. And where it says server should be another computer. I am not sure what happened there. But this is how communications happens when they're all connected. The C3 controller communicates back to the server and is in constant communication with the server, and that's the way the computer and the panel communicates, just back and forth with the constant communication. Question about the time zones, if you don't mind, Ms. Shannon or Mr. Remind me after the course. I'll go over what a time zone is for you later on. Oh, that's what I forgot. I got fancy on myself. Okay, so just back up 1 second. I forgot that I had put this in here. So software is installed here where database is. This is the controller. Communication is between the two all the time. And if you have another computer that you need to log on to that's outside of the server, would be your client machine. So let's say the receptionist is on the client. This server would be in the IT room. This panel controller, C3100, would be in the IT room as well. And this is how communication would go between all of the devices. This green arrow here would just be network connections between them. And PC's running Windows. I'm not sure what you're asking there, Jamie Hood. Our next panel is going to be an embedded web server or web-based controller. And the two that we offer is a CanSec panel and the ZK Techo Atlas panel are the two web-based options that we have here at Flake. Benefit of this one, you don't need software. You don't have to install software, and you don't need a server in order to connect to this panel, because the software and the database is embedded in the controller, which just means the software is on board the device. And to you, Richard, yes, your server could be located at a corporate office and talking to multiple remote buildings, controllers. Yes, sir, Richard, that can happen. And that's usually how it does work for the bigger, in the bigger environments. So when you log into a browser, so Google, Internet Explorer, Firefox, all the browsers would work and certain ones not. So Internet Explorer, I'm normally good, whereas the latest one that they have, I've had some issues with. So sometimes you just have to try a different browser. But you log in using an IP address, which IP addresses are built like this with four sets of numbers. So a 192.168.0.1. That's just an example, but this is what you would type into your web, into the browser, and then it would bring up the page. Am I still clear? I got a message that I'm breaking up. Am I breaking up, or is it all good for some of you? Chris, I see you. Hello, can you still hear me? Can everyone still hear me? You still? No? Yes, or have I lost you? Got you back? Good. Okay. So I'm all clear now? All right, good. Still clear. Good. Okay. All right, I'll just back up a little bit. All right. Embedded web server, web-based. I'll just start over. The system does not need software installed because the software and database is embedded inside of the device, the controller. So you would log into it via web browser. And that may be Internet Explorer, that may be Google, Firefox, but you'd log into it using an IP address. So for those who are needing to get situated and learn more about computers, IP address is something you want to be make that term familiar to you. So example of an IP address is 192.168.0.1. You would type that in your browser. Each panel is going to have a default IP address, and they're generally different from manufacturer to manufacturer. You'll get something different. So you just look in your manual and find out what that IP address is. So once you're logged into the panel, you'll most likely program a new IP address into that, just depending on your IT generally. And if you need an IP address, you would ask the IT department for one, or if they prefer you to use something in specific, in particular. So the same applies here. If communication is lost to the controller between the whatever computer you're logging on with and the controller, updates cannot be made until communication is reestablished. So if everything that's in the panel before you lost communication will still function, and anything that you try to add after that will not make it there. Joshua, the instructions are generally they're pretty detailed. I would always recommend with this course, take as many notes as possible, get familiar with relays and different terms, and the instructions, you'll get there using the instructions. But all of the platforms, for the most part, are all the same. They're going to look different, but they're going to function the same. So we'll move on to the next one. And this is just a diagram of how communication happens on the web-based panel. You can plug your computer directly up to it, or plug the controller up to the customer's network. Your computer is on the network, and then you could access the device. And again, the software is embedded inside of the device on the panel, which makes this one, the web-based systems, a little easier. I want to say easier. It makes it a few steps less to do a web-based system because you don't have to install software. Okay, we're going on to the next one. Next, we have the cloud-based system. So cloud-based is the latest type of access control platform. In the beginning, I was skeptical, I can say, about it. I wasn't comfortable with it, but I'll explain, go over the list, and I'll tell you why I wasn't comfortable until I did my first one. So cloud-based doesn't require a server, PC, or software installed on a PC to access the system. The reason behind that is that the server PC is at a remote location, usually a server farm. So the handful of cloud applications that I've done were all hosted by Amazon Web Services, and they just have a location that has a building full of servers, and they are the host for the cloud-based scenario. The PC and software is maintained by the company hosting the service, the cloud-based service. So you don't have to maintain the PC, and you don't have to maintain updates for software. All of that is pushed down automatically by the host. Whoever's hosting it pushes it all down all the time. So your database, all your locks and inputs, outputs, they're all programmed by the installer from a PC or a phone from anywhere at any time. So the benefit of a cloud-based system, there's going to be RMR involved. You can there's monthly fees involved with doing cloud-based systems, so you can make some money on it, and also you can access it at any point. You don't have to be on site to access it. There's no special um, ports that need to be forwarded or anything of that nature that has to be done from the host. So if you need to troubleshoot for a customer, you can just log in remotely from your phone to check. Or if you want to add, you can add that way for them. It's really neat, but the customer must understand they pay monthly fees, and the monthly fees that they pay, generally the installer gets a portion of it. So we just went over that. There's monthly fees, and they're charged for the fees, or they're charged generally door. Each door they so all these questions, I'll just check them off and get back to you on them later. So the installing company, each one is different. If needed, after this, we'll go over, or I can get you the information, you guys, on specifics. Okay, can't hear me. Has the audio come back? I have a few people that said that I am frozen. I'll just stop for a second until audio is back. Everybody, please let me know. Okay. Please let me know. And is it back? Can you hear me? Or am I still breaking up? Guys, am I better? Vocal security says it's better, but is it better for everybody? All right. Okay, where do lost you at the fees? Good, good. Just please continue to let me know when it breaks up, and I'll stop for a second and let the lag catch up and start back over. So it looks like somebody said the last things they heard were fees. So I'll go back to the installing company can make RMR off the fees associated with a cloud-based system. So some of the manufacturers have it already set up where you pay, the fee is paid, and the manufacturer then pays the installing company off of that fee. So the one that I know that does it like that is CanSec. But if we need specifics, we can go over that later on. Email me or call me about it, and we'll figure it out for those platforms. So sound is I see somebody said it's bad again. What about for the rest of you? Is the sound doing okay? Good, good, okay. So for this particular system, this is going to be the same with communication. If communication is lost, updates will not make it to the controller and cannot be made until communication is established. And I'll go back to where I started on the cloud-based system. I was used to just doing server-based systems, and web-based a little. So when the cloud-based system came up, I couldn't understand why we needed to have the server, what I was used to having on site, why it had to be somewhere else in somebody else's space. Um, but the company said that that's what they wanted, so we went ahead with it. And after installing it, um, the panels, they all came online immediately. I had no issues with connecting to it, and there was never a time that I couldn't log in. I thought that was going to be an issue. Like when it's time to log in, if there's an issue, then what happens? Because you can't just call anyone. But I didn't have any issues logging in. And when the customer had issues, I was able to just log in over my phone and diagnose the problem. And then sometimes I didn't have to run the call. I didn't have to leave and get in the truck and travel, 40 minutes to the site to fix a simple issue. I was able to resolve it over the phone. So there are benefits to cloud-based systems, and a lot of companies are going this way. For cloud-based, we have the CanSec panel, which is cloud-based, and we have ISONAS, which is cloud-based as well. And yes, you can. Yes, Mr. Matthew, I can get that email to you after this. And I would say for your access control, if you could do a server base and a web base first to get the hang of it, get used to the relays and time zones and all of the lingo, it would probably be easier for you to take that route first and not take the cloud-based route first. Not that it can happen, but if you're trying to get familiar with terms and used to, if you're just trying to get familiar with it, just say you're brand new, I would do a system or two first and then approach the cloud-based system after that. Now we're going to go to the next site. I thought you could remotely log into IP system as well. I'm answering Chris's question about remotely logging in. His question is, I thought you could remotely log into the IP system as well. So if you're talking about a web-based or a server-based system, Chris, you can log into a web-based or a server-based system remotely, but ports have to be forwarded on the network. So provisions have to be made in order to allow you to log in remotely onto the computer, into a specific site. So you're going to need IT to get involved to open ports to get into the system. So for example, I have a cloud-based system here on site that I use for demo purposes in our will call area. And when I set it up initially, I had to get with IT because our network was actually locked down really well, and he had to open ports just to allow me to get out. So it just depends on your network and how it's built on and how you'll be able to connect. And that's for Chris's question. Yes, so cloud would be a little easier to remotely access out of the gate, Chris. Initially, yeah. You don't have to make the arrangements as many as you'd have to do for logging into another type of system. Okay, and any other questions before we move on? I'll answer another question. I see Sal has a question. He asks, where can we go to get hands-on installation experience? Um, it's a good question. Some of the manufacturers that I've done training for, you would get hands-on with, but you would have to go to their facility. So this involved me traveling to New York, to Florida, um, to get that experience. They'll have controllers and panels there for you to test and play with, but it'll be just their equipment. So you'll learn only one. What I always like to do, if you get a job, I take the panels, the controllers, I'll bring them home and I'll set it up at home so I can learn how it operates first. So when I get on site, I'm not learning how it operates. So it's time. You're going to use your time, your home time, but home time doesn't cost you money. Like being on the job and learning on the job. This is going to be difficult to sometimes learning on the job. So I would do it at home if possible for all. So whenever there was something new, I just bring it home and play with it and test it at home. When I get on site, I may have to default the device to get it back to the factory specs, but I've learned how to use it, and when I get on site, it's just easier. Let's see. Let me check another question for now. We won't answer too many, but let's see. So, Chris, do you think ICLES is as secure as IP? Do you think cloud is as secure as IP? It's from Chris again. And I'm going to say yes. I do think it's secure. All IP applications have some possibility to be broken into when it comes time to network. That's just what it is. We have to be realistic. There's hackers out. There's some people's jobs are making sure the network is safe, and some people's job is breaking into network. So I had issues. That was another one of my concern cloud-based, that the device wasn't on site and the communication between the two could be intercepted. In all reality, communication can be intercepted are some classes available at trade shows, or do we have to go to a trade school for actual training? Yes. Oh, Chris, is it still going in and out? Or can you guys hear me? I got a message and I'm fading out. Fading. Feels lagging. Okay, I'll give it a second. Give it a just came back. Is it good again? You're back. Good. Okay. All right. Perfect. I hope Tim, we got him back. Good. Okay. Just continue to let me know when we lose, when connection isn't great. As you all know, there's a lot more people like I. So this is just a diagram of how a cloud-based system would look. you would have the controller, which is this CANSEC MEP1 controller, and the communication is out to the cloud. Okay, let's back up. It's lagging. Is it? I see it as somebody's lost me again. Has it come back, or is it still lagging? Losing me. Can everybody hear me still, or is it? Are we good? All right. Somebody respond, please. Keep going. Right. Got it, Richard. Good. All right. Okay. So this is just an example, a drawing. I did my best to show how it works. So it's actually a bidirectional arrow, should be bidirectional. So this will be the cloud. It communicates to the cloud and back down to the controller. The same way to the phone, the same way to this Dell over here, and also to the laptop. They could all be anywhere at a given point and connect to that controller and make changes and see what's going on in the device at any point at any time. And we're going to move on to the next slide. So our last type of scenario is an app-based system, which Kerry makes an app-only system. It's called IntelliProx Blue. No, the picture isn't very clear, but IntelliProx Blue by Kerry is the app-based system. So pretty simple system. It requires no software and no PCs. All you need is a compatible mobile phone or tablet. You can do all programming of your doors, door contact, request to exit, locks, cards, card holders, time zones. You can program everything. You have to program everything over the app. You cannot access it any other way, only through an app. So the database is stored on the panel and communication is Bluetooth, which I give it 60 feet. Manufacturer, I think, gives it 120 feet. When you have walls, concrete, bricks, all of that will affect your distance of how far you can be. So for this particular controller, generally I would put it above the door. So if I had to access it, if I'm at the front door, if I had to access it, I left my card at home, I'm within range of the door, I can log into the app, go in the app and hit the unlock button and it would unlock the door. You can run an audit trail from it as well. You can do majority of the things you can do in a PC-based system, but it's scaled down. You can't do all of the features. Like a keypad reader won't work with this. There's no option to use a keypad. So, I mean, but it works well. I have a demo as well here, and I think we'll be looking to do a demo of this one as well. So we're going to go on to the next. Good, you can see and hear me. That's perfect. This is the way communication goes from this, from phone to the device, and the device to the phone. Pretty simple. Cost is really effective on this one as well. Wait, I have a question. Tim, are you having issues with the audio or video? Next, we'll cover our parts of an access control system. So you can see our pictures here. You're going to have a controller. you got to have some type of power supply, a lock, some type of reader, card reader, biometric. Um, you have the door contacts, request to exit, and credentials. And Joshua, your question: do you need a phone to unlock it, or is there a card reader? For the IntelliProx Blue, there's a card reader that works with it. There's a card reader that attaches to it, and you would generally program cards and hand them out to your customer and actually show them how to program cards. So it'll work with the card, but what I was referencing, if you leave your card at home and you're the administrator and have access to the app, you can log into it if you're within Bluetooth range and unlock it through the app, is what I was saying. And last is going to be credentials. So for our pictures, I have a Rossler reader. I have a request to exit, have a mag lock with the LED on it, a controller, and I have a power supply with enclosure is what I have in the picture. Oh, I went too fast. Did I go too fast? Yeah. Sorry about that, guys. So we're on the controller portion of it now. So all of the systems are going to have a controller. If you're doing some type of access control, you're going to have a controller. Even a standalone, the reader, pen reader, card reader, that would be the controller. So an access controller, aka you may hear called the panel or the controller, it is the main backbone of an access control system, which just means it's basically the brain of the access control system. Most scenarios, that panel is not visible for most people because it's generally installed inside of an IT room. The reason why is so no one has access to it, or the wrong hands can't get to the panel and possibly damage the panel or try to manipulate it so they can use it to enter into a space. So that's why we generally keep it in a IT room. Above ceiling is always good as well. If you don't have an IT room or in the manager's office, but I would try to put it in a as secure place as possible. So when an access control credential is presented, which is just a card or a fingerprint, it'll compare the input to the database to determine whether it should be allowed to a particular door or a particular time of day. Control panel receives the access card credentials from the reader, and it compares it with the rules configured for the access card based on the same access allowed or denied. The door will lock or open or can remain open. When the relay triggers, the lock is being powered or loses power. That's how we will unlock a door. We're going to either send it power or we're going to cut the power. This is how access control panel control the access activity for buildings, a building's doors. And the controller will have connections for the selected credential reader, a relay output, a door position, and if you're using door contacts and rexes, you'll use the door inputs for the rex. So in panel, most panels that we carry, they're going to come in 2 or 4 door. We have one of them you can get that has a 1 door panel. This IntelliProx Blue is a one door class, 1 door panel as well. but between 2 and 4 is going to be the basics to what you'll get. When you're selling systems, keep in mind if your customer wants 2 doors and you notice that their budget says they can do 2 doors, but you notice that they really need 4 doors to secure their space, might be a good idea to get the 4-door panel, so you don't have to purchase another. For some of the systems, if you buy a 2-door panel, that's all you get. You'd have to purchase another. So just keep that in mind when you're working on systems, or you're getting ready to quote a customer. Think about the growth and growing their system and what would be best for you and them. And I'll look at a few questions. Let's see. We'll answer that one later about Rosslayer. They have their own software. I'll just go to the next slide. I'll come back to the questions. I'll try not to make this one too long. I don't think we have a bunch more slides. So here's going to be one of the most important parts, a really important part, is your power supply. It's a key component because it provides power to your locks, motion detectors, and you can also use it to power your controller as well. Key component to power supplies is a battery backup, which means that if your power was lost to the power supply, the batteries would keep the unit running until the batteries die. We'll go over that a little bit more later on, but battery backup comes into handy. Customers say, look, I want the system to continue to run even if I lost power. And they say, well, I need it to run for 2 hours, 3 hours. Then you would have to calculate how many batteries you would need to keep that system up and running for that 3 hours. It's not very hard. We'll go over a little bit with power and amps later on in the slides. So choose your power supply wisely, especially when you're doing many doors. 1-2-door scenario, you can get away with the plug-in transformer. I always recommend using a power supply with an enclosure, but it's a little more costly than that plug-in transformer. But if you plan to do more, we should always go with a enclosure. So whenever it's time to pick a power supply, you want to take all of your devices that are going to be in the system. So you'll have a controller, you have readers, you have locks, everything that's going to be plugged up on that power supply. You want to get your specs and see how much power it will consume. And then you add it up. Once you come up with the figure, you'll know, let's just say, for example, you have 3 amps total. All your devices come up to 3 amps. It's always better to have more than enough power. So for a 3 amp system, I would go with at least 4 amp power supply. If you plan on growing it or you know it's going to grow, you go even bigger. Go with a 6 amp. But we'll go over a little bit more and power a little later on. Come back to you on that one, Tim. So here's a few examples of power supplies. So we have a plug-in transformer, which I know most of you are familiar with. We have the power supply with the enclosure, which is the one right next to the transformer. We have the power supply board, which is right below the enclosure. And then we have distribution boards. This distribution boards were my favorite. I didn't realize that as many people do not use them in the smaller space. In integration, this is what we used all the time, distribution boards. It allows me to control, send power to devices separately and have them fused and not have one big jumbo of wires. And if you get a short in one big bundle of wires, you get a short, sometimes you can blow out everything. So the distributions are a safety measure. I like them. Have any questions on them? I'll get you part numbers and pieces on them. And I want to do a video on power supplies, and I have one with the distribution board with two distribution boards in it. We'll go over that one, give or take, in a couple of days as well. So let me get to two questions. Let's see. So do you need to hire an electrician to wire in the power supply with enclosure? You do not have to hire an electrician to wire in the power supply. If you want power to be directly connected to this power supply, then I would say, if you're not familiar with electrical, yep, get your electrician. But you could also buy the pigtail and plug it up to this power supply and plug the power supply into the outlet. There's 3 wires, hot, neutral, and ground. And you plug it in like you do any other device. So you don't have to have an electrician. It just depends on your scenario. Josh, okay, see, doesn't have a system. Okay, I have another question. Does any system require licensing fee? I've got a quote from ZK Techo Panel, and they added license fee. Yes, so if you get ZK's Pro Panel, you're going to have to get license for readers and different features in the software. But the Pro Panel is the enterprise. That's their enterprise version of a panel. So whatever they quoted you was the Pro Panel, and that's why you would have most likely needed license. If you get the other ones, the C3, the Alice panel, there's no license involved. For the Alice panel, there's going to be a license involved for Alice when it's time to use your phone. You get 1 free license for phone, and then it can go up to 5 phones, I believe. In order to do the 2 through 5, then you'd have to purchase a license to unlock the 2nd, 3rd, 4th, and 5th phone. But for the most part, with ZK, you do not have to have license for your equipment. Got another question here. Can I get the info on the power supply distribution? Yep, I'll get that to you after, Mr. Carlos. Let me make a note of that, your question. Yep. And right, depending on the AHJ. Yeah. And just, I'm reading this, Joshua, in my state, you must have a low voltage license to wire access control. Yeah, every state is different. So every state requires or doesn't require certain things to do low voltage. It just depends. Get into your local, your state laws and see what's required where you are. And once you determine that, I could then help you pick parts and pieces maybe that may fit your scenario. But you have to know what your state does and how they go about it in that particular state. Going to go on to the next slide. So now we're at the lock. So in the locks, we'll have a fail secure lock and a fail safe. So a fail secure means that If power is interrupted or fails, the device, the door, it will stay locked. That's why they call it secure. Um, its default state is locked. So if your secure lock stays locked when the door when power is removed. However, because the door keeps being locked in emergency, typically it will be unusable with a mechanical override, such as a regular key. So let me back up a little bit. A fail secure lock means you need power to unlock it. Normal state would be locked. You send it power, it would unlock that device. That's how a fail secure lock works. A fail safe lock means you need power to lock it. So a mag lock, all mag locks are fail safe. You need to have cut the power. It'll cut the power to the lock, and then that would unlock it. That would make you have a fail safe lock. Depends on your scenario on what type of lock you need, fail secure or fail safe. Generally, I go with fail secure unless the customer asks for fail safe. But generally, I will go with that fail secure. Unless they get a mag lock. If they get a mag lock, it has to be fail safe. Okay, I see a few questions going, but I'll get back to those. So most fail-safe locks are used at main entry points like office doors, lobby access doors. Most popular, what I found used for this application are mag locks, and they require power to operate. Most locks can be fail-safe or fail-secure, and some are field selectable, which just means if you get a lock and it's field selectable, you can make it fail safe or you can make it fail secure on the fly. Generally, it's some locks you have a button, some you have a dip switch, some you have to take a screw and make it change the direction. It just depends. But a lot of door strikes nowadays are field selectable and allows you to just purchase it, and then you can make it fail safe or fail secure if you need it. What we have is electrified hinges, and if you electrified hinges are common, but I've seen more used the door cords in this field. So, but if you use electrified hinge, that would allow you to get power to your cylindrical or mortise lock or your crash bar, and then you won't have any exposed wires or anything to grab onto. Like if you use a door cord and you're at a school, I would recommend using a door cord up high so the kids can't just go by and grab it and pull on it and possibly pull the door cord out. So a little food for thought. Here's a bunch of scenarios of locks, just a handful. So up top, we have the 600-pound mag lock, top left. To the right of that, we have a 1,200-pound mag lock. Below that, this lock here is called the shear lock, which is a mag lock that is recessed in a door frame. And this plate here would be recessed into the door. It's made for dual swinging doors, and it's called a shear lock. I've seen it used on a gate scenario as well, where the mag lock was recessed inside of the gate frame, and it actually worked pretty well. I didn't think it was going to, but it worked out pretty good. We had to create a bracket for the armature plate, but the position of the mag lock in the gate, it helped. To the left of that lock is a electrified cylindrical lock. Below that is just a trim, electrified trim, which would work with a crash bar. You have an exit device and you don't want to put a motor on it. You could use this trim, electrify it, and it is pretty simple. I don't see them a lot anymore, but we move a little bit of them. Here is a rim strike, which can be used with the exit device when you don't want to electrify the exit device. Here's the Adams Wright Hawk latch, E-Hawk, I believe it's called, electrified. Here's an electrified mortise lock and an electrified crash bar, turnstiles, and another form of turnstiles. Oh, sorry about that. And I'll go on to the next one. Here's just an example of a mag lock. It's made by RCI. And I want to make you familiar with mag locks when you're purchasing them. A bond sensor, which is up top. If you get a mag lock with a bond sensor on it, it's just a sensor on the lock that can tell when the plate is actually fully engaged. So you would generally have a LED at the bottom of the lock. When the mag lock is open, LED would be one color, say red. Once it's engaged and in the lock state, fully engaged, the LED will go late. It would turn green, and that's called a bond sensor. They come in handy just if you have somebody who's sitting behind a door, and they could actually just look up at the lock to see if the door is actually completely locked or not. You'll also run into a door status sensor in the mag lock, which is no more than the door contact built into the mag lock. When you install your armature plate, this black piece here in the armature plate must line up with the door contact in order for it to work correctly. So when installing your mag lock, please be sure to use the template when installing the mag lock. It helps. It has saved my life in the past. Okay, on to the next. Here's a bunch of examples of just electrified hinges. There's just several options of hinges out there, just depending on what your scenario is and what you want to use. You have the basic electrified hinge, picture number 3. You have that piano hinge, I believe they call it in picture 4. 13 is common, a common hinge you'll see used often. 14 is an induction coupling. I have never used it, but it's for sale, and it allows power to pass wirelessly through those two devices you see in image 14. It's not recommended for fail-safe devices. It's recommended for fail-secure devices. So only when you need to pass power through it. They didn't recommend having power pass through it at all times. And picture number 10 is a door cord. It is the most commonly used item that I've seen here at Flake. I'll get to my next one. If you have a door and it doesn't have a pathway, you're going to use a mortise lock, electrified mortise lock, or electrified cylindrical lock. You'll have to core the door, which just means you're going to drill a hole through the door from end to end. And I would get a device. We sell, Flake has this device. We sell that device. You attach it to the door. It has a pivot on it. It allows you to center, get where you want to be to drill your hole. You clamp this device onto the door. Make sure you have the line that you wanted before you clamp it on, and you drill out the door. So you'll run the drill in and then pull out the trash, and run it in and pull out the trash, and eventually you'll make it to the other end. If you don't pull out the trash and you're drilling on the door, what's going to happen is going to cause that drill bit to want to misdirect and not go straight because it has trash in there, and you'll probably end up coming out of the door like you didn't have this device anyways. But this device actually, I think it takes me about 10 minutes to do a door, and it takes me 5 to 7 minutes just to set up the device, and drilling the door doesn't take long at all, as long as you keep your door sharp. And right, Jamie made a comment. Don't do this to rated doors, because it will compromise the rating of the door if you start drilling on it. So you have a fire rated door, you may want to get with a company that can drill that door for you and recertify the door. I've had that. I've run into that before. On to the next one. Here's a card reader, several different versions of card readers. Card readers are used in physical security systems to read credentials that allow access through access control points, typically a locked door. A reader can be a proximity reader, smart card reader, or a biometric reader. So left to right, we have two prox readers, the first two readers, one Rossler, one HID. We don't carry HID, I just put it in there because you'll see those out in the field quite often. That third reader is a biometric and a prox reader by ZK Teco. The next reader, fourth one, is it's a Bluetooth reader. So you could use your phone as your credential and use it to get into the space. You would use your phone and it would unlock the door once you have credentials on your phone. And that's by, that reader is by ZK Teco. Next, we have a prox reader and a pin reader. And the last one is a Rossler. It's called the long range reader. You would typically see them in parking lots. So the read range would be a little bigger than just a standard reader. So when you're driving up, you don't have to actually touch the reader to use the car. You can be a foot away from the reader and get into the gate or whatever the space is. And this reader by Rossler is also Bluetooth as well, that last one. Any questions about those, just send them on over to me and we'll get those answered after this. So next we're going to go over door contacts and REX, which is called a request to exit, but you'll commonly see REX switch. So a door contact is a device consisting of a sensor and a magnet that is attached to a door in the frame. So when the door is open and the magnet separates from the sensor, a signal is sent. And this will let the security system know that the door has been opened. The door contact is one of the most important parts of an access control system, in my opinion. Request to exit, which can be request to exit motion detector. It can be a request to exit switch in, say, a exit device or a mortise lock or a cylindrical lock. And it is an accessory in the access control system, which can take the form of anything, and from a mushroom button to an infrared sensor. in the system, the REX trips a relay in the panel to bypass a door forced open alarm. So which means if you are utilizing the door contact, the REX, when you're using the door contact and the REX, when you leave the space, the REX picks you up. Either you turn the handle, it picks you up, or the motion detector goes off. When you leave the space, the REX will tell the system someone is exiting. So it doesn't think somebody entered into the space without using their card. That's the purpose of your door contact. And also if you want to monitor the status of a door or know if somebody's propping doors open, you want to use a door contact as well, just to monitor the status of the door. So that REX switch can be in any number of things, like we said earlier: cylindrical lock, mortise, exit device, even mag locks. I saw one recently. There's a mag lock on the back of the motion detector. It was a part of the built into the mag lock. So if a door contact will be used, a REX must be used in order for the system to function as designed. And if you don't use that contact, you're not taking full advantage of the access control system. Credentials. So credentials are no more than a key fob, a card, a fingerprint. They'll come in several different shapes and sizes. There's stickers, a bunch of different credentials. So proximity cards are generally going to be 125 kilohertz, and the format will be 26-bit. You'll see this, the bit of a card. It'll come up quite often. Most of the systems that we have, you don't. It'll work with the 26-bit. All of the systems we have will work with the 26-bit. It just depends on when you start getting into these odds, or the customer needs a specific card. We have to make sure we have the right type of credential. If you have a customer who's using an existing system or existing cards, let us know so we can make sure we get you the right stuff. So it says this format uses a facility codes, sometimes called a site code, and the facility code is a unique number common to all of the cards in a particular set. So we have clamshell cards, thin cards, and printable cards. Clamshell would be the thick card. It's pretty solid, doesn't bend. You have the thin card, is light, and it can be bent pretty easily. And you have printable cards. Printable cards are if you're going to print like pictures on your cards, you want to go with that. But then you would need a card printer as well. If a customer ever asks about, yeah, I like to print on my cards, and a printer has to be sold with it. And if that happens, let us know really early, because you need to have, you need to make sure we get the right equipment that's going to work with the printable cards. Next, you have smart cards. I'm sure some of you have heard of smart cards. They are 13.56 megahertz. And it differs from the proximity card, and it holds more information than just the basic card, the basic prox card. So the proximity card and the prox card has only one function. The reader is an embedded operating system for the smart card. So the smart card just does a whole bunch more. Mark's Mark Wester. I'm taking 20 over Mr. Mark. And for the smart card, It has a on. The card is going to be a little more. Can work in several different applications. So okay, guys, can you hear me? Looks like I'm back. Hang on, right? Okay. Can you hear me? Can anybody hear me? Oh, can you guys hear me? We're on there. Feeding. You're back. All right, perfect. Person back. Good. You can hear me. All right. Perfect. Yeah, somebody might have been trying to get to the Lion King on the computer in the back or streaming some videos. Good. Okay. All right. We left off at smart cards. Loud and clearish. I like that, Mr. Joshua. Okay, so we were at smart cards and I was at they can handle multiple application smart cards. So it can be not only used for an access control system, it can be used like at a college where they can use it to get into their rooms. They can use it as a debit card. They can use it to do a number of things because the card has a lot of applications that can be run on it. Okay, I'm give Mr. Michael a chance to connect. Question. So we have the smartphones, we have fingerprints and facial recognition as credentials, can be used as credentials. Smartphone is probably the feature you're going to hear about the most coming here in the future. What we're going through with the virus and all this other stuff, you'll probably run into a lot more readers that would work with your phone, and also facial recognition will probably uh, be coming around really quickly as well. I'll probably have a video for facial recognition for sure, because I'm waiting for some of those to come in. But I guarantee you, you'll start seeing more of this now. Joshua, I have not seen do they make a printable smart card? I have not seen a printable smart card, but I can verify that for you after this. We finish with this slide. And good, screen's back. So mobile technology and biometrics are believed to be the future of access control. Mobile technology is particularly popular with younger generations because everybody has phones, and they use their phones so much and keep them in their hands so often. And mobile credentials have the ability to control more than just access control, which adds convenience to the factor. Keep in mind, mobile credentials generally have a cost associated with them. Like you'll purchase a bulk, a handful of credentials, and then issue them. So the way they're generally issued, the administrator would send an email to, let's say I'm going to get mobile credentials today for this site. The administrator would send me an email. I would reply to the email. Once I reply, I then download the app, accept it, and then that credential goes live on my phone, and the credential in that app would have a number associated with it. To add it to the access control system, I then add that number into the system, just like I add a regular card into an access control system. It's pretty neat, and several manufacturers are making them. They'll be around. Actually, they'll probably start to be more common as time goes on. And lastly, so there are different types of credentials, ID and HID. And there are two different types of cards, and one will not read on the other. So an HID formatted card will not read on, say, the baseline ZK Techo reader that you would get with the kit. It would be in this ID range. If you needed a HID reader, you have to specify, I need HID readers, and then we'd have to add an HID reader for you. I'm sure most of you, if you're looking into access control, have probably run across a HID reader. For a while, HID, they had this format for HID, was only theirs for many years, and then here recently, the other manufacturers were able to tag on and start to use their technology for HID. For any questions about that, we'll have to go over it. We can go over that later. If you have any questions, just email me or call me. Let me go to the next one. Oh no. Give me a second, guys. It's always issues. This is our first time doing webinars, and we have run into a little issue, but give me a second. I'm going to take that off, and then you'll see it again here, guys. All right, I know this isn't very clear, but there's just a few pictures of credentials. The key fob, the key ring. Here's a card, another card. The one in the middle by Rossler is what you would use with a long range reader. You could attach it like to a car, like in the grill of a car. This one isn't made for the window. This one is made to be outside. So the one to the left, the AWID one, this one would attach to your window, and the one below it would attach to your window, and then you could like an easy tag, what they call it here in Texas. It would just attach to the window. When you pull up, the reader would pick it up and unlock the gate and will allow you to get in. So keep in mind, you don't have to use cards. You have options when it's time to pick your card. When it's time to, especially when it's time to go through a gate, it's often much easier to not have to roll your window down, use a card, and just pull up and have the gate open. Okay, so next I chose to go over power and electronic terminology, just to cover it briefly. It's not going to be in depth on power and electronics. If you guys need it, please let me know, and I'll go over that. Give me 1 second, guys. Hang on. Okay, I'm back. Power and electronic terminology, just to go over it briefly, just to kind of get you, if you have zero knowledge, this would give you something to start with when it's time to get into working with low voltage. The most common voltages are 12 and 24 volts DC. There are two types of voltages in low voltage you'll run into. You'll run into direct current, which is called DC, and alternating current, which is called AC. The most common you'll find in access control is going to be DC. More often than not, you'll run into DC. DC means direct current, and that's an electric current flowing in one direction only. AC is an alternating current, and that's an electric current that reverses its direction many times in a second at regular intervals, typically used in power supplies. So amps, keep that in mind. You'll hear this quite often. And if you see a device and it shows 12 volt, 12 VDC, and then it has 2A behind it, that A means amps. That means the device is 12 volts, and it can draw 2 amps. So amps is a current is measured in amperes, but it's referred to as amps. And 1,000 milliamps equals 1 amp. The reason I wrote that, most devices are going to consume in milliamps. So like a door strike, basic door strike would consume, I think, about 250 milliamps. So if you were using 4 of them, then those 4, if they all fired at the same time, would consume 1 amp of 1 amp. So you would need at least a 1 amp power supply. And for this one as well, we can go over this. For anybody who has any questions on it, we go over it. Send me a message. We'll go over it. So there's a fused outputs. Fuse is a safety device consisting of a strip of wire that melts and breaks an electric circuit if the current exceeds a safe level. So it's just a fuse. And if you throw a short, the wire is going to get hot and then blow a fuse. that comes in handy with your when wiring things in the field. You don't have to worry about burning up a device. You can just blow a fuse, replace the fuse. But if you do not have fuses and you throw a short and it goes back to, say, your controller, and you blow it, you have to buy another one and then reprogram it. So uh, it's cost effective to use them. Uh, there's what we call it. They have a PTC fuse, which is a PTC resettable output, which is a polymeric positive temperature coefficient. Just call it a PTC. And like a traditional fuse device, it reacts to heat generated by excessive current. So basically, a short or too great of a load, a fuse melts, open and interrupting the circuit flow, whereas a fuse interrupts the current flow, but a PTC limits the flow as it rises, and it can reset. So a PTC fuse, if you use that, if you end up with one of those devices that has a PTC fuse on it, it'll throw the short, it'll cut power. The moment that it cools off and gets back to the operating temperature, it'll go back to normal. So if the short is still there, what's going to happen is just going to short out again, allow it to cool down. So it's just a resettable fuse. Me personally, I have used the PTCs, but if I have an option, I'll choose the fused outputs. A tool that's needed in access control is a multimeter. It is going to be the best tool that you put your spend some money on. Right here is the multimeter that I use. It's a Klein, picked up from Home Depot for $60. It would make your job a lot easier when you start getting into many doors or when it's time to troubleshoot issues. It will make everything a lot easier. Having a multimeter definitely will save the day. And what is a relay? Relays are going to be on every panel, every device. Anything you're doing with access control, you're going to have some relays involved on hardwired access controls. And relays are just switches that open and close circuits electronically. And that's what allows you to get in and out of that door. We are just about over, guys. This is how you would go about calculating power. So if you had all these devices, if you guys are building the system, this is what I came up with. My controller consumes 750 milliamps. Controller uses 750 milliamps. My card readers use 70 milliamps a piece. My motion detectors, they use 50 milliamps a piece. My mag locks are 12 volts, 500, 24 volts, 250 milliamps. That'll generally be the case all the time. 24 volts are used less. And my Von Duprins take a 1 amp, need 1 amp of power, right? So once you take all of that and add it all up, 750, 280, 205, I came up with about 3 amps of total power, give or take what I need. So I went with a 4 amp power supply. This Securitron AQD 4 means it's 4 amps. But if we're looking at other power supplies, we would just make sure we find one that is a 4 amp power supply. At least 4 amps. You want to go at least over where you need to be. Don't want to go under, because you go under, then you take a chance. If you really are consuming up all of the power, eventually you'll just burn the power supply up because it can't put out enough power to those devices. So having more than enough is always better than not having enough. And we are coming to an end here, guys. The recommended tools, just if I had to make a list, a cordless drill, multimeter, what we talked about, tweakers, which is no more than small screwdrivers like this. Get some bigger ones, some of the longer screwdrivers. You'll need them for working on the panels, because the panels will have very small screws. Um, that's a must. A toner, if you're going to get into electronics, go grab one. Maybe not initially, but over time, a toner definitely will help with working with electronics. Um, I'll go over that as well. We'll probably do a tool video, show how the tools work. So drill bits, a unibit, hole saws, and extensions. So when I say extensions, you want to be able to extend the hole saw. And in case you need to drill a hole into a frame and the hole saw is not long enough, you get the extension that allow you to drill into the frame and maybe into the next space, maybe the sheetrock or so. Glow rods, those are for pulling cable. They'll come in handy. Pulling cable up and down walls, through ceilings, they'll save your life as well. Tape is very important. And sheetrock saw, which most of you probably already have. And I think, yep, that will be the end of the slides. And I only have about 9 minutes before the event will end. If we have any questions, could send over your questions. I will send my email address for you guys to have. So there's my email address. If anybody has any questions or any ideas, if you guys have anything that you may want to see a demo of, go ahead and send it over to us, because we have quite a bit of time now with the current situation to do more videos. And after this video, I think I can get into doing some more specific videos like electrified crash bars or electrified strikes or maglocks, and showing how they work with motion detectors, how push buttons work, just a whole bunch of different things. If you have any input, please send it over to me, and we'll start working on it. I'll sit here and wait and see if anybody has any questions. But at 8 minutes, it'll end anyway. I thank all you guys for coming by and taking the 2 hours to sit with us. I know I had a few issues, but this was our first go, and we will do many more, and most of it is going to be specifics from this point forward. Mr. At Tim asks, what software do you recommend with Rossler? Rossler has their own software. It's called Axtrax, like AXTRAX. And hopefully everybody took down the email. I didn't put my extension. Let me go ahead and put the extension as well. Extension 287. Thank you, guys. Thank you. Mr. Tim, did you get that answer about Rossler? All right, we got 5 minutes. It'll be wrapping up. So if anybody has any questions. No, no questions. Good. Thanks, Mr. Alfredo. Thank you. If y'all have any questions, we are open and we'll be open. We'll be here answering the phones. And I'll start working on the next video. Yep, that's right. That's right, Tim. Extracts. And if you have any other questions about it, Tim, give me a call. Extension 287. Yes, Andre, you can receive credit hours. You must email travis.howell@hlflake and tell him that you're looking to get your CEU hours for this course. Again, if you need to get CEU hours, send it over, email to travis.howell@hlflake. Can I do a wiring and software? Yep, I plan to do a software video already, Tim, and wiring as well. I plan to do quite a few videos. We're going to pick some panels and see where we're going to go. If you have, Tim, if you have something in mind that you'd like to see software wise that we carry, send it to me and I'll tell you if I have it. I have several platforms. I have ZK Techo's Atlas. I have the ZK Techo C3 panel. I have Rosslayer. I have CanSec. I will have Isonis soon. Send it over if you're looking for something in particular. But a wiring video, yes, we plan on doing that as well. Mark, any standalone keypads that have one-time use pin codes? I'd have to look into that one. Mark, can you send that over to my email? Rosslayer. All right, got it. I'll take a note of that, Tim, on the going over the software. So video may be with me or it may be with myself and a Rosslayer representative. It just depends. But we will have many more videos to come. I'll look over all the notes and see the ones that I didn't get to. The questions I didn't get to, I'll go over those and go through the notes and see what else can be used. If y'all have any ideas, feel free, send it on over to us. We'll look at them. We definitely have the time. And everything is going online nowadays anyway. So I guess it would be the best time for you guys you can grab this information now while we have the time. Okay, no problem. So Rosslayer will be on the list. Is there anything else? Send it on over. Chris, I got 2 minutes. Oh. Yeah, hang on. Travis. Howell. So email Travis and ask about the CEUs, and he'll get it over to you. I got 1 minute before everything is going to shut off on us. If we have any other questions. Chris.